What's up, everybody? Welcome back to Basic Chemistry 101 with SIHLE BONANI. My name is SIHLE BONANI, and today we are doing atomic theory of matter.
Let's go. This is for every child that wants to make it one day. Zimbo say class and presence of mind is elsewhere. Bring out Uzuzani, Afna Wolfie, Dante. Already Alispani, and the timer is nowhere. I know your pain, you don't have to be scared.
Remember when we spoke about Louis Lavoisier? He's the guy who is one of the pioneers of modern chemistry. Now, for basic theory of matter, there's a guy called John Dalton. He's a British physicist, no, a British chemist actually. He is the one who said that all matter is composed of small particles called atoms. Now, in the previous session, we defined a compound, we defined an element, we defined a chemical reaction in terms of matter. Now, in this session, this guy, John Dalton, he is coming up with a theory of atoms, which is your atomic theory. Now, he came up with the basic statements or postulates to define element, compound, chemical reaction of an atom. So you have to understand what is an atom, what is an element, what is a compound, what is a chemical reaction according to Dalton's postulates for you to understand the atomic theory of matter. So the theory on its own, which is the atomic theory, it explains the structure of matter in terms of different combinations of very small particles called atoms. Now, these are the postulates as we've spoken before. One, as an atom, he said that all matter is composed of indivisible atoms. Atoms are very small particles which retain their identity during any chemical reaction. So what he means is that everything is made up of atoms, which is those small particles, and they cannot be divided any further. Remember, this is a theory. Now, he also, his second postulate or his second basic statement, he spoke about an element, which is a kind or type of matter which is made up of one type of atom, with an atom each having the same properties. So in an element, each atom that makes up the element has the same properties, and he spoke of such properties as mass. So according to Dalton, he said each atom in an element always has the exact characteristic mass. That is the second postulate. And number 3, he spoke about a compound. A compound is a type of matter which is made up of one type or more types of atoms. Now, these atoms are chemically combined. Now, also this type of atom, they are chemically combined in fixed proportions. He said that 2 atoms in a given compound occur in simple ratios. So from there, I think if you can remember when we spoke about the law of definite proportions, I think this type of a postulates, it speaks back to the law of definite proportions, in which is there's fixed ratios of those atoms in a compound. And also the last postulate, he spoke about chemical reaction. A chemical reaction, it consists of rearrangements of atoms present in the reacting substances to give new chemical combinations present in the substances formed by the reaction. He also said that atoms are neither created, destroyed, or broken into smaller particles by any chemical reactions. So what is basically saying, if you have a chemical reaction, there is an exchange or a rearrangement of atoms there. So there is nothing really that is changing. It's just a rearrangement. So in these postulates, what is he came to explain, or he agreed with the laws that we had spoken about earlier, the law of conservation of mass. Let's say postulate 4, the rearrangements of atoms in a chemical reaction. If there is a rearrangement, chances are the mass will remain constant. So that is the law of conservation of mass. And also we had already alluded to the fact that he also speaks about the law of definite proportions, which is in a compound, each atom has a fixed ratio in such a compound. Also, he also came up with his law as well, which is a law of multiple proportions. And we will not be explaining that. We will ask for help from anyone who's watching to explain what is the law of multiple proportions according to Dalton. So that is the atomic theory of matter, which came up with a guy called John Dalton. So from here, from the things that we had spoken about earlier, we also spoke about a theory being a tested explanation, but a theory cannot be proved fully. So chances are a theory, it changes from further experiments. And for us to explain that, we will go to an atomic structure, and we'll explain that just now. Yeah, so we start with atomic symbols. Now, an atomic symbol is a representation of an element, which is a 1 or 2 letter notation to represent atoms in a particular element. So how do you write those symbols? For a particular atom or element, it has a name. So the first letter of that name will be used in capital letters. So if you have hydrogen as your atom or element, you would use the letter H. But if you have two symbols, the second letter is in small letters. So for an example, for your chlorine, you'd have C, which is the capital letter, and then your L in small letters. Now the second letter is in the name. Chlorine, there is an L in chlorine. But you'd find also there are elements such as iron. Now iron does not start with F, but they use other languages such as Latin. So iron in Latin is used as ferrum. So that's how you would represent your elements or your atoms as atomic symbols. Now you find that John Dalton said atoms were indivisible, but further experiments went on to find out that atoms are divided into two. They are divided into a nucleus and electrons. So your nucleus is the central core of an atom, and then around atoms you find one or more or many electrons which are situated around. Now the nucleus is positively charged and your electrons are very light particles which are negatively charged. So an atom on its own is divided into two particles, which is your nucleus and your electrons. And now you also find that in your nucleus, the nucleus also is divided into two, which is your protons and neutrons. One other thing, the nucleus, it makes up most of the mass of the atom on its own. So the nucleus, it has protons and neutrons. Now protons are positively charged and neutrons have no charge. But the charge of your proton is the same charge as the charge of your electron, but the mass of your proton is 1,800 times that of an electron, and the mass of your neutrons is almost the same as that of your proton, almost equal to the mass of your proton. Now in your atom, you'd find that the protons can be used to identify a certain element. So protons, the number of protons can be used as your atomic number. It is used as Z. So your atomic number can be used to identify. For an example, hydrogen has 1 proton in the nucleus. So the atomic number for hydrogen is 1. Now you also find that there is the mass when you add the total number of your protons and your neutrons in your nucleus, you get what is mass number. Mass number is a sum of your protons and neutrons. Now, when your protons and neutrons are added together, you get what is called a mass number. For sodium, you find that the atomic number is 11, which is you have 11 protons in sodium, and the mass number is 23. Now, when 23, it means you have 11 protons and 12 neutrons, which make up your mass number. So that is how your atom is structured and how it is divided. But sometimes you find that other atoms have different mass numbers. Now this is because some atoms, when they naturally occur, they have different number of neutrons in the nucleus. So you have for sodium, you'll always have 11 and 23. Your atomic number and mass number is always the same, because sodium naturally occurs like this. So from there you won't have any changes. So this one will be called your nuclide. But for cases such as oxygen has different mass numbers, which is 16 and that's 16 and 17. I don't know. 16 and another one. Let's say it's 17. But the 16 mass number is the most abundant. But when you have different mass numbers, you come up with what is called your isotopes. Your isotopes are elements with the same atomic number but different mass numbers. So that is what you would get when you are talking about an atomic structure. I think we have covered almost everything. Now we'll have to move on from there. Where do we go? Okay, there's nothing further. We are done. See you in the next video. Please subscribe, comment, and leave us a like. Thank you very much. This is Basic Chemistry 101 with SIHLE BONANI. I am SIHLE BONANI. See you next time. Booyah!